Give me maximum 1 minute. If you finish doing first 20, you just keep on doing remaining questions also. Then consider the following statements about scalars and vectors. Now we have a good understanding about scalars and vectors. Statement capital A. It says that a scalar only has magnitude. That's correct. Scalars only have magnitude. That's correct. Statement A is correct. Statement B, a vector has a magnitude and direction. Yes, a vector has a magnitude and direction both. Statement B also correct. Statement C, multiplying of vector by a scalar. Multiplying of vector by a scalar always gives a vector. Look at this idea. I explained. 3 statements. Statement capital A, statement capital B. So you will agree statement A and B correct. Statement capital C. Now they mentioned when you multiply a given vector by a scalar, the result is always a vector. That statement also correct. Why? Because in theory class I explained that vector multiplication by a scalar. I said that if there is a vector, I told you if there is a vector, let's say vector simply. And when you multiply this vector by a scalar, my scalar going to be capital K. Then I explained that then the result is going to be when you multiply a given vector by a scalar, the result going to be another vector, a new vector. The result going to be a new vector. The result going to be a new vector. Then based on the value of K, I told you that this new vector's magnitude is right. Now let's say now magnitude of vector is simply magnitude of vector is simply. And when you multiply this vector simply by the scalar capital K, the result is a new vector. And also magnitude of the new vector, I told that is the multiplication of this scalar with this magnitude of the previous vector. So I told you magnitude of this new vector going to be K into A. K into A. This story I told you. It's a new vector. I name this new vector as vector B. This new vector is vector B. Its magnitude going to be that scalar that you multiply the scalar into the magnitude of vector A, Ka. Its magnitude going to be Ka. Magnitude. In order to represent the magnitude of a given vector, we are using a modulus. I told you. So when you write the given vector B, and if you write this given vector inside inside two vertical lines, this is the meaning modulus of vector B. That means magnitude of vector B. That's going to be equal to K into B. This story we learned. Nice story. We learned this story. Okay. Then statement capital is also correct. Remember, when you multiply a given vector by a scalar, the result is going to be a new vector. Its magnitude is going to be equal to K times the magnitude of previous vector. Okay, that's the idea. But remember, based on the K value, sometimes K can be a positive value. K is 5. Sometimes K can be negative value. Remember, next important point. Remember when K is a positive value. For an example, let's say K is 5. Okay, I will show this story. Now, there's a vector. I say 1 Newton. It's a force vector. Its magnitude is 1 Newton. I name this vector as vector, simply vector. Its magnitude is 1 Newton. Direction is this direction. Now I'm going to multiply this vector by a scalar. Now my scalar going to be, let's say 3. My scalar is going to be 3. Then remember, the result is a new vector. The result is a new vector. I draw here. The result is a new vector. Magnitude new vector I marked as vector B. Remember, magnitude of vector B going to be 3 into the magnitude of vector A. Magnitude of vector is 1 Newton. The scalar is 3. Then magnitude of vector B, the newly formed vector must be 3 into 1, 3 Newton. I think now you understand. Direction same as previous direction. Rather than this scalar is a positive value. What would happen if the scalar is a negative value? Same story, same story. 1 Newton. Now learn. My target is not completing the stories. My target is explaining every point properly and giving you theory points. Right? 1 Newton. 1 Newton. The vector is simple. Rather than multiplying this vector by a scalar 3, if I multiply this given vector by a scalar minus 3, I'm going to multiply this by minus 3. The negative value. If my scalar is a negative value, then what will happen, sir? Again, when you multiply a given vector by a scalar, the result is same as a new vector. The result is going to be a new vector. The result is going to be a new vector. The new vector. This vector is, I mark it as vector C something. I name this new vector as vector C. If I want to find the magnitude of this newly formed vector, its magnitude going to be equal to the scalar into magnitude of the previous vector. 1 into 3. Same as 3 Newton. But remember the direction. Since I'm multiplying by minus, the direction going to be opposite. Story. Summary stories. If you want to write something, you can write down. Write down. Okay. Then statement C says what? Statement C they are telling. Statement C they are telling. Write down. Now when you're writing somewhere else, write down the stories. Because now you understand. Now you remember. But after, just think that, can you remember what we learned in dimensions? It's been more than 1.5 months that we have done dimensions. But now can't remember, right? We have the idea, but we can't remember. Likewise, remember these things also, you will forget very easily. It's very normal. We as humans, we will forget these stories. But the best option is better write down everything I say. Whatever I say important, if you feel this is important, quickly write down somewhere else. Okay. So statement C, multiplying of a vector by a scalar always gives a vector. That's correct. Then all statements A, B, and C are correct. The right answer for question number 1, MCQ1 is 5. Nice story. Nice story. This is a nice story. So then number 2, which of the following physical quantities represents a pair of vector? That's easy. Option 1, speed and displacement. We know speed is a scalar, displacement is a vector. But they're asking in the question, pair of. Which of the following physical quantities represents a pair of vectors? Then both of them must be vectors. Option 2, weight and acceleration. Weight is a force. Yes, weight is a vector. Acceleration is obviously a vector. Now you know. We are learning these days linear motion accelerations. Therefore, the right answer going to be option 2. Therefore, the right answer going to be option 2. Therefore, the right answer going to be option 2. The right answer going to be option 2. The right answer going to be option 2. Okay, right. So question number 2, I'm not discussing anything. Answer is 2. Right. Next story. Next story. The next story. Third one, that is also, I think, very easy question. Which of the following physical quantities is a vector? Energy is not a vector. You will learn what is energy in mechanics. Nice lesson. Work energy power is a nice lesson. Energy is a scalar. Speed is a scalar. Pressure is a scalar. You will learn what is pressure, hydrostatic pressure, everything you will learn in hydrostatics. Nice lesson. My favorite lesson in unit 2 mechanics is, my favorite subsection in unit 2 mechanics is hydrostatics. Personally, I like that subject. Personally. Pressure is a scalar. Angular momentum, remember, rotational motions, you will learn that what is angular momentum. Remember, angular momentum is a vector. Power is a scalar. So therefore, now you might feel that you have no idea about what is angular momentum. So therefore, sometimes you feel a bit difficult to get the right answer. But remember, angular momentum is a vector, power is a scalar. Answer for third one is fourth one. That's easy. Question number 3, answer is going to be 4. It is 4. And these things easy. And then fourth one. Fourth one going to be, which of the following physical quantities is a scalar? Now they have given density is a scalar. Option B, acceleration is a vector. C, pressure is a scalar. Simple capability option, energy is a scalar. So then option A, density. Option C, pressure. Option D, energy. They all are scalars. So therefore A, C, D. Therefore, answer question number 4, answer is 5. I'm not explaining in detail for those stories. Question number 4, answer is 5. Question number 4 answer is 5. Question number 4 answer is 5. Okay, right? Then next idea. Next idea, fifth one. Now listen to this story. This is important. For two homogeneous vectors to be equal. Now I explained what does it mean by two homogeneous vectors. When I was teaching vectors, we learned about homogeneous vectors and heterogeneous vectors. Can you tell me what is homogeneous or what is heterogeneous? I explained homogeneous means same type of vectors. Homogeneous means same type of vectors. Heterogeneous means different types of vectors. For example, we all know that when you consider two force vectors, one Newton force this direction, other vector is 100 Newton force that direction. When you consider two force vectors, they are homogeneous, same type, force. But when you consider displacement vector and force vector, they are different types of vectors. That means they are heterogeneous. That's very simple. Then vectors we know we can divide into two categories. One is homogeneous vectors, same type, force, displacement, velocity. Other one is heterogeneous. Homogeneous. Other one is heterogeneous. This story we know. Heterogeneous. Okay, this story we know. We learned. I taught you. For two homogeneous vectors to be equal, I taught you. Option A, the magnitude of two vectors must be equal. Definitely. In order to consider two vectors are equal, I told you that magnitude of both the vectors must be same. Direction of both the vectors must be same. Both the vectors must be homogeneous. And both the vectors must be parallel. Can you remember the conditions? In order to consider two vectors are equal, magnitude must be same, direction must be same, they must be same type homogeneous, and they should be parallel. Then option A, magnitude of the two vectors must be equal. Option A is correct. Option A is correct. Option A correct. Then capital B statement. Statement B says that the two vectors should be represented by two straight line segments parallel to each other. Now the question they are telling, for two homogeneous vectors to be equal, option 1 is magnitude of those two vectors must be equal. That's correct. Statement A is correct. And we'll go to statement C. When you go to statement C, direction of two vectors must be equal. Direction of two vectors must be equal. Statement C also correct. So I hold statement B. Statement C also correct. Statement A is correct. Magnitude must be same. Statement C, direction must be same. These two are correct. No doubt. No argument. Statement B. Statement B now, the two vectors should be representable by two straight line segments parallel to each other. The two vectors should be representable. The two vectors should be representable by two straight line segments parallel to each other. Now remember, this is the idea. If two vectors to be equal, magnitude must be same, direction must be same, homogeneous. Then remember automatically those two vectors becomes equal. Now statement B telling two vectors should be representable by two straight line segments parallel to each other. That statement is correct. But for the question they are telling two homogeneous vectors to be equal. To be equal, capital B condition is not a must. So when magnitude and direction equal, you can tell that they are equal. It's not capital B statement is correct, but not a must. So therefore, question number 5, A and B correct, C is wrong. So the right answer is only A and C. Answer is 4. Hands up, this story, clear hands up. Still, I'm talking the basic stories. Till I didn't come to the right questions in vectors. Hands up, this story is clear hands up. How many of you understand what I'm explaining hands up? The story I'm explaining is very clear hands up. This story. right? Now, if you came to the class from the beginning, you understand. If not, you don't understand. Don't worry. First of all, give priority to watch the recordings of linear motion. Then start watching the recordings of dimensions and vectors. And in August, I will start some quick cover-up classes also for online people and physical class students both. Cover-up class. Then you will be able to manage it, right? Just be patient. Okay. Then this is also done. Next story. Next story. Question number 5. Answer is then fourth one. Answer is fourth one. Question number 6. Which of the following diagrams correctly represent the addition of two vectors 8 Newton and 6 Newton? This story. Can you remember now? Can you remember in vectors, if you want to add two vectors graphically, if you want to now remember in vectors, addition of two vectors and resultant of two vectors give the same idea. Remember, addition of two vectors and resultant of two vectors, they are same. By finding the resultant of two vectors or by adding two vectors, the idea are same. Then if you want to add two vectors, if you want to find the resultant of two vectors, we learned two different methodologies. I told you about revising. Addition of two vectors. Addition of two vectors. Addition of two vectors. Remember, addition of means remember resultant of. Remember, addition of means there's another word for addition of, that is the resultant of. There's another word that is resultant of. Resultant of two vectors. Addition of two vectors means remember resultant of two vectors. One method is graphical method. One is graphical method. Other method is algebraic method. Arithmetical method. Graphical, other one is arithmetical. Graphical method, other one is arithmetical. This story is explained. Graphical method, other one is arithmetical. Arithmetical. When it comes to graphical method, how many laws that we learn to find? Raise your hands. If you want to find resultant of two vectors, if you want to find the addition of two vectors, and if you are going with a graphical approach, if you are going with a graphical method approach, how many laws that we learned to find the addition of two vectors using graphical methods? Raise your hands. We learned one method answer. One method answer. So we learned two methods. We learned two methods answer. Two methods. Three methods answer. Three. If you want to find the addition of two vectors, then we learn two methods. One is triangle law of vector addition. Other one is parallelogram law of vector addition. There are two methods, remember. There are only two methods. Don't tell polygon law, that is for more than two vectors. One is triangle law, other one is parallelogram law. Not important to get the answer. Triangle, parallelogram. Parallelogram. Arithmetical, we can remember we learned some equations. I will come. Second option is arithmetical methods. We learn some equations. Give me some time. Right. Okay. We learn some equations. Now I'm going to talk about triangle law. So when I do the questions, we have 60 questions to be discussed. So when I'm doing those 60 questions, step by step, I will discuss every section again. I revise everything again. Now triangle law vector addition, we can remember. Triangle law. I'm already explaining triangle law. Triangle law, remember that when there are two vectors, if you want to find the resultant vector, what have you done? So you can consider any of the vector. Now in the question, they have given two vectors. They have given the question two vectors. One is 8 Newton, other one is 6 Newton. One is given as 8 Newton, other one is 6 Newton. It seems like, look at the diagrams. When you look at the diagrams, it seems like 8 Newton vector is a horizontal vector. And 6 Newton vector is, when you look all the diagrams, 6 Newton going to be a kind of vertical vector. Can remember how did we apply triangle law? Start from one of the vectors that you love. Now I love to start from 8 Newton horizontal vector. Okay, 8 Newton horizontal vector. This vector is 8 Newton horizontal. Magnitude is 8 Newton. So we all know that from the point where you finish drawing the first vector, you should start drawing your second vector. Second vector is 6 Newton. You should start drawing second vector 6 Newton from the point where you finish drawing first vector. This is the point I finished drawing first vector. Start drawing 6 Newton from this point, 6 Newton upwards. But you want to remember, arrows must flow in one direction. These arrows, 8 Newton and 6 Newton's arrows must be flow in one direction. Either it's in clockwise direction or anti-clockwise direction. Then right. You started drawing the diagram from this point, initial point. You drew the two vectors. Final point is here. Then I told you that when you connect initial point and final point using a straight line, that straight line going to be the resultant, if not addition of initial to final. Arrow must be pointed from initial point to final point. That's going to be the resultant vector. So this is the idea. So then which of the following correctly represent the addition of two vectors 8 and 6 Newton? Then we all know that this is 8 and this is 6 Newton. And we all know that resultant vector is capital R. Can you find the magnitude resultant vector capital R? We learned right angle triangle means we can use Pythagoras. Pytho. When we apply Pythagoras, parallelogram law I will teach later. I will explain the Pythagoras. So we can tell that capital R squared hypotenuously, capital R squared must be equal to 8 squared plus 6 squared. All level maths. 8 squared means 64. 6 squared means 36. 64 plus 36 is going to be 100. R squared 100. R squared 100. Since I want to find the magnitude of capital R, subject capital R. When you subject capital R going to be root 100. Root 100 is just in. 10 Newton. Finally. Not difficult question. Simple questions. Practice. 10. R is 10. So then the best, the right diagram is, we know what is the right answer then. By satisfying all the stories, look at the arrow direction and look at the magnitude. The right answer going to be, I think, second one is the right answer. No, not second one. Third one is the right answer. Third one is going to be right answer. Third one going to be right answer. Third one. Answer is 3. Nice. Arithmetical stories also I revise you when I do questions one by one. Next idea. I discussed. No, we are not doing for now. We finished the class by 7:30 or 7:45 something. So therefore, we are not taking the break anything. Right. Okay. The right answer going to be third one, right? Because fourth one is wrong. Because fourth one 8 Newton right side and 6 Newton upward. Resultant must be from initial to final. But fourth one, final to initial. Fourth one is wrong. Right answer is third one. If you have doubts, you can ask. Then next story. Question number 7. Before doing 7, we'll go to 8. Eighth one. Consider the following statements. A. The addition of two vectors always results a vector. The addition of two vectors always results a vector. It's correct. Here, addition of 8 Newton and 6 Newton results a new vector. Magnitude is 10 Newton of the new vector. Direction is this direction. You can measure the angle if you want. If you want, you can measure the angle of new vector. So therefore, question number 8 statement A is correct. Addition of two vectors always results a vector. That's correct. Question number 8. Statement A. Statement A. Statement A. Statement B. Statement A, addition of two vectors. Uh, addition of two vectors always results a vector. That's correct. That's correct. Statement B. It says the product of vector and a scalar always results a vector. The product of vector and a scalar always results a vector. That's correct. When you multiply a given vector by a scalar, the result is always a new vector, a different new vector. Therefore, statement B also correct. Statement B also correct. Statement C, something you are not very familiar. Statement C, somewhere else write down also. Somewhere else in your notebook also write down statement C. Statement C, what they are telling. Statement C, they are telling. The product of two vectors always results a vector. Remember, when you multiply a vector by another vector, okay, just think, I'm asking your opinions. What do you think? Now here I explained that when you multiply a vector by a scalar, the result is a new vector. Ratio and how many we say? When we multiply a vector by another vector. For an example, just multiply force and displacement. Force is a vector. Force is a vector. Multiply force by displacement. When you multiply a vector by another vector, ratio and how many we say? Always the result is a vector. Hands up. What do you feel? Hands up. So if I multiply a vector by another vector, the result is always going to be a vector. Hands up. That's like this. Remember, some stories are there. Some stories in your syllabus you will learn. I just take that example. If you don't understand, forget about it. When I do that section, I will revise you. Now in your syllabus, in work energy power, you are learning an equation. Work done. Work done means capital W means force into displacement. Hands up, how many of you learned this equation when you were doing all levels? Hands up. Work done means force in displacement. You might have done. You might have learned. Another equation I will tell you. I will take you. The torque. Torque means, if not, we are calling it as moment of forces. Moment of force. If not, we can call it as torque also. I think you learned that equation also. We were learning in deep in A levels. We will learn upcoming chapters. Torque means force into perpendicular kind of displacement. Perpendicular kind of displacement. If I draw the diagram for your understanding, not important. There's a force. The perpendicular distance to the force from the point of rotation. You don't need to bother with this. Even you don't understand, forget about it. Now, when you look at these two equations, they seem like very similar. Work done, force into displacement, kind of displacement. Torque means force into kind of displacement. Remember, in here, when you multiply a force by displacement, force is a vector, displacement is a vector. When you multiply force, a vector, displacement, that is also going to be kind of vector. When you multiply a vector by a vector, the result is work done. Remember, work done is a scalar. Work done is a scalar. Remember, work done is a scalar. See the idea? Then we can come to the conclusion. Some people might think, sir, if you multiply a vector by a vector, always the result is a vector. That's wrong. Always means wrong. When you multiply a vector by a vector, the result can be scalar also. Sometimes vector also. We can't exactly tell always when you multiply a vector by a vector, always result is a vector. Wrong. When you multiply a vector by another vector, the result can be a vector as well as result can be a scalar. In this scenario, force vector, displacement vector, when you multiply them, the result is a scalar. But in this story, torque equals force into the perpendicular distance, kind of displacement only. In this story, force is a vector. This is also a vector. The result is a vector. Torque is a vector. You will learn. So therefore, remember, somewhere else write in your notebook also. If you multiply a vector by a vector, always the result is not going to be a vector. When you multiply a vector by a vector, the result can be a vector. The result can be a scalar. It depends. You can't exactly tell without learning this, without knowing these phenomena. If you never learned about work done, if you never learned about talk, then you have no idea. Ne? So therefore, just somewhere else write down. If you multiply vector by vector, result can be a vector, result can be a scalar. That's enough. More than enough. C, this question C. This question C, they told that the product of two vectors always results a vector. That's wrong. That's wrong. So therefore, the right answer going to be option A and B. Option A and B, right answer going to be second one is the answer. Question number 8, answer is second one. Nice story. Nice story. So seventh one, I will give a separate note and I will teach you. Don't worry. Then we'll go back to ninth one. Right. Ninth one. The vector A and B are parallel and equal in magnitude. The vector A and B are parallel, equal in magnitude. Which of the following statement is correct? Now they have given two vectors, vector A, vector B. They are parallel and they are equal in magnitude. Which of the following statements is correct? Nine and 10. Amen. Evil eye. Right, 9. Ninth one. Ninth one. 6:52. Maximum are staying with me for maximum 40 minutes. Right. Vectors A and B parallel. I just roughly draw. Maybe my two vectors, maybe these are my two vectors, maybe. I want to draw an arrow, but now I don't draw an arrow, but there are two vectors. These two vectors are parallel. Vector A, now normally vector simple A, this is vector simple B. They are parallel, we can see. I haven't marked direction, but definitely by using an arrow, I want to mark the direction also. I will mark the direction later. There are two vectors, they are parallel, having same magnitude. This magnitude also same magnitude. Same magnitude. Which of the following statements is correct? Option 1, the lines representing A and B geometrically form a rectangle. The line representing A and B geometrically form a rectangle. Not clear, we'll see. Option number 2, A and B cannot be added together. A and B cannot be added together. Remember, when you consider any two vectors, you can add them together, right? Any two vectors that you can add together. Therefore, statement number 2 is wrong. Obviously, statement 2 is wrong. Statement 3, they mentioned that vector A equals vector B. And statement number 4, they are telling vector A equals minus vector B. Very confusing. Even I also have no idea. We'll go back to statement 5. The above requirements are necessary, but not sufficient for A equals B. What they are telling? What they are telling? Right. Okay. Look here. This idea. Okay. Now here. Okay. Careful listen. Listen carefully. This idea. This idea. So why the arrow of 10 Newton is opposite direction? Okay. Got it, sir. Right. Look here. Wait a minute. Give me 1 second. Look here. Look here. Now they have given two vectors. They have given two vectors. They mentioned they are parallel. And they mentioned they are having same magnitude. Let's say magnitude of vector A also, let's say simply, magnitude of vector B also simply. They are having same magnitude. They are parallel. But we have no idea This is your vector A. We have no idea whether their directions are same direction. No. Right? We have no idea. These two vectors direction are right side. No. A's direction is right side and B's direction is left side. We have no idea. They haven't given the data. Right? Very clear. Out of given five options, out of given five options, the problem is they haven't given the direction of vector A and vector B. That's the problem. In case these now vector A's direction can be right side, vector B's direction can be right side, vector A's direction can be right side and vector B's direction can be left side, vector A's direction can be left side and vector B's direction can be right side. So we have no idea about the directions. Without knowing the directions, we can't argue everything properly. Statement number 2 is obviously wrong. A and B cannot be added together. That's wrong. If there are two vectors, definitely we can add them together, no doubt. It doesn't matter whatever the directions or whatever, we can add them together. Number 2 is wrong. Number 3, they are telling A equals B. Can we consider this vector A and vector B are equal? In case if their directions are right side, oh. In case their directions are left side, then we can tell that vector A and vector B are equal. What if vector A's direction is right side and maybe vector B's direction left side? Can we consider vector A and vector B are equal? We can't consider. If the directions are different, we can't tell. Just because their magnitudes are same, we can't say they are equal. Therefore, A equals B statement is also wrong. We can't tell properly because they haven't exactly mentioned the directions. Can we tell vector A's direction is opposite to vector B's direction? In case A's direction right side and B's direction left side, then we can tell A's direction is vector A equals minus vector B. What if both the vector directions are right side? So therefore, we can't tell fourth one also correct. And fifth one, the above requirements are necessary but not sufficient. Above requirements are necessary but not sufficient for A equal B. Right? So this is also not clear. But the line representing A and B, the lines representing A and B geometrically form a rectangle. Now, when you complete this, it's creating kind of rectangle. Now, if you complete this, creating kind of rectangle. So, therefore, we can consider option 1 as correct. Option 5, we can't, it's not clear option 5. This 9-story hands up, clear hands up. Question number 9-story, clear hands up. Question number 9 is clear answer. Question number 9-story, clear answer. Raise your hands, how many of you understood what I explained answer? This idea answer. This idea, clear answer. It's clear. It's clear? Right, okay. So then, next story. Then, question number 12. Now, 10 and 11, I will come in, don't worry, question number 12. Now, this is sometimes the first time only you are experiencing this type of vector question. The magnitudes and directions of 4 forces acting on the object are represented in the figure by OA, AB, BC, CD. The resultant force. Okay. Now this is the first time that you are doing. I think this is the first time that you are doing. Look at the story. Nice question. Question number 12 is nice question. 12th one. First of all, I do the diagram. So in your case also, you also try to draw the diagram. Diagram is important. If I do the diagram is this type of diagram, kind of rectangle is there. Then there's a kind of triangle. Right. This point going to be point O, point capital A, point B, and this is point C. This is point C, point capital D, point D, point C, point D. Okay. Now they mentioned magnitudes and directions of four forces. How many vectors are there? There are four vectors. Four forces acting on an object are represented in the figure. They have given the four vectors, four forces: OA, AB, BC, CD. Now they mention OA vector acting right side, magnitude is P. When you consider AB vector acting upward direction, magnitude is 5P. When you consider BC vector, this direction, this vector's magnitude is 10p, 10p, 10p. And when you consider this vector magnitude is 5p, 5p. In the question, what they're asking now, remember these lines are not representing any vectors. Huh? These lines are not representing any vectors. Right, there are four vectors: OA, AB, BC, CD. Okay, right. Now my question is, now I'm not doing anything. Just I will ask your opinion first. First, I'll ask your opinion first, and let's see how many of you are in the track and how many of you understand the stories. It's completely all right. If you didn't understand, completely all right. Every question learn something. Let's see how many of you understood. Raise your hands. Now they have given 5 answers. They are asking what is the resultant of these 4 vectors. What is the addition of these 4 vectors? That's what they are asking the question. They're asking when you add those 4 vectors, because we know when we add vectors means result is a new vector. When you are adding vectors means the result is going to be a new vector. They're asking what is the new vector when you add these 4 vectors. The resultant force, the resultant vector. Raise your hands. How many of you say the right answer is option 1 answer? The right answer is option 1 answer. Sir, the right answer should be option 2 answer. So the right answer is option 2, sir. Right answer is option 2. Sir, I think the right answer must be option 3. I think right answer must be option 3. Sir, I think right answer must be. It's got stuck. I think right answer must be. Okay, again I'm asking. And suppose is right answer is option 1 answer. Right answer must be option 1. Right answer is option 2. Answer. Right answer is option 3 answer. Option 4 is the right answer. Option 5. Okay. I have no idea about this question answer. So I have no idea. I don't know how to find the result answer. So I have no idea. Genuinely, I have no idea actually. Genuinely, I have no idea. Genuinely, I have no idea. Right. Okay, very good. Very good, huh? Very good. Now see, now always try to link that triangle law, parallelogram law, polygon law, polygon law, polygon law. Now sometimes suddenly when you look at the diagram, sometimes you don't get the idea. So this practice, this idea by looking at the diagram, sir, I want to apply triangle law for this question. So I want to apply polygon law. So I want to do this way. That idea, suddenly that idea comes with the practice. Now what you just think about polygon law. Polygon law. We can remember polygon law means if you want to find the addition of more than 2 vectors, we can use polygon law. If you want to find the addition of more than 2 vectors, we can use polygon law. What is the idea of polygon law? Polygon law says that polygon law is very similar to triangle law. Polygon law is very similar to triangle law. Let's say there are 3 vectors. There are 3 vectors. Let's say one vector is right side, other vector is upward, and other vector is this direction. Then polygon law says that now represent those, start from any of the vector. I start from horizontal 1. From the point where you finish drawing the first vector, start drawing the second vector. You can select any of these 2 as your second vector. This is my second vector. But remember, arrows must flow in same direction, like how we follow this triangle law. From the point where you finish drawing second vector, start drawing a third vector. But arrows must be flowing same direction. Initial point is here. This is the point where I start drawing the vectors. Final point is here. When you connect initial and final point, that is going to be the resultant vector. That is going to be the resultant vector. Okay, this is the polygon law. See Miller, very nice story. Now when you look at this diagram, now only thing is you want to apply polygon law. There are four vectors. Just think starting from point O. Now imagine starting from point O. First vector OA, right side. From the point where this vector finished, started drawing second vector AB upwards. See, OA vector direction and AB vector direction, they are in same direction anti-clockwise. So normally this direction we are calling as clockwise. Like how you are second and minute and hour hand, what follows a circle, that direction we call as clockwise. This type of direction we are calling it as anti-clockwise. Now we understand OA vector, first vector is right side. Second vector, from the point where I finished drawing first vector OA, I start drawing second vector AB upwards. From the point where I finished drawing the second vector, third vector BC. From the point where I finished drawing the third vector, fourth vector is CD. But you want to remember, one condition must be satisfied. All the directions must be flow in one direction. See, so their directions are following kind of anti-clockwise direction. The directions are following kind of anti-clockwise direction. In case in the diagram, see, in this diagram, okay, they are following in anti-clockwise direction. Then this is some kind of a polygon law direct substitution. OA right, AB, BC, CD. Then started drawing the vector from point O. You ended drawing vectors at point D. Now tell me what should be the resultant. Now tell me what should be the resultant. Anyone can tell. Sir, there are four vectors. If I follow polygon law, if I draw the vectors OA right side, I finished at point A. I start drawing AB vector upwards. I finished at point B. From there, I started drawing BC vector. Point C, I started drawing CD vector. Finished at point D. Then you taught us the straight line connecting initial point and final point. The straight line connecting initial point and final point going to be the resultant, sir. According to what you taught us, so this OD, going to be the resultant vector, sir. According to polygon law, this OD going to be the resultant vector, sir. Agree? Hands up. Now this story clear hands up. The resultant is OD vector hands up. This resultant is OD vector. That story now clear hands up. Resultant is OD vector. Now the next story is, what can you say about OD vector and AB vector? I'm going to ask you one question. Just consider OD vector and just consider AB vector. What can you say about OD vector and AB vector? Raise your hands. How would we say? So OD vector and AD vector, they are equal vectors. They are equal hands up. OD vector and AD. Sorry, my bad. OD and AB. OD and AB. Raise your hands. How would we say? OD vector and AB vector, they are equal hands up. They are equal. There are conditions. There are some conditions. Magnitude must be same. Look at this right angle triangle. The two parallel sides. Right angle triangle. Two parallel sides have same side length. Magnitude wise, they are same. OD and AB have same magnitude. Nice story. When you consider OD vector and when you consider AB vector, AB, they are same in magnitude. Magnitude wise same. And direction, same, right? Upward direction, OD, AD also upward. And they are homogeneous. That's obviously force vectors homogeneous. And the last condition is parallel. They are parallel. OD and AB are parallel. Then we can tell that, right? We can tell that if you want to put, you can put the last condition also parallel. So therefore you can tell that therefore sir, OD vector and AB vector are equal, sir. Nice question. Therefore sir, OD vector and AB vector are equal. Now tell me then, what should be the magnitude of OD vector? What should be the magnitude of OD vector? So they haven't given the magnitude of OD vector, but they have given magnitude of AB vector. That is phi p. Then sir, OD vector's magnitude also must be phi p. If you consider OD vector and AB vector are equal, magnitude of OD vector and magnitude of AB vector must be same. Therefore, OD vector's magnitude must be 5p. This story. Generally hands up. This story is clear hands up. This story is very clear hands up. Answer is first one hands up. Very clear hands up. Hands up. Very clear hands up. Very clear hands up. Very clear hands up. Very clear. Very clear story. Right, okay. Now, okay. Likewise, don't worry. We are doing lots of questions. Right now, you don't know now. Even you learn polygon law. If I don't do a question like this, you have no idea. Here we want to apply polygon law. Here, if we just apply polygon law within 1 second, we can get the answer that idea. You don't get. Remember, in A levels, especially subject like physics, just because you understand the theory, that does not mean that you understood the theory. Theory means in physics questions. In physics, theory means questions. More the questions that we do, that means we are finishing theory properly. More the question that we are doing means really we are finishing the theory properly. Then only you can do that. Then only you can do a proper A-level exam paper. Yes. Okay. Done. Nice question. But we on the next one. See, next one also a beautiful question. Question number 13. 13. After class finishes, it's your responsibility. You must. I will bring some kind of implement to do this homework stories properly and check your homeworks, and based on the way, I don't mind whether you get the right answers to the homeworks, but I want to assure that you all are doing homeworks based on your hard work. How much amount of hard work that you have put for your homeworks, based on that, I will do something. I will give kind of reward something or kind of give something. I don't mind. I will do that upcoming days. Okay, 6 coplanar vectors. Now there are 6 vectors: AB vector, BC vector, DC, vector ED, vector EF, vector FE are represented in the figure. The resultant of these 6 vector is, again I draw the diagram. Question number 13, again I draw the diagram. Question number 13, I am drawing the diagram. We have to stop the class at 7:30 something. But anyways, when we start a paper class, normally paper class duration may be 2.5 an hour or maybe 3 hours. But it will increase with the time. Question number, this is nice question, question number 13. Question number 13. 13 story. If I do the diagram, this kind of diagram. Now, once you learn this question, now you can argue, you can think this question in this way. That's why doing many questions is important. Then what? So you also draw the diagrams. You also should draw the diagrams. You guys also should draw the diagrams. Right. How many vectors are there? There are 6 vectors. Then they tell AB vector. Where is my AB vector? It seemed like confused, but you guys don't confuse. Please don't confuse. Huh? AB vector. Here is my A. This is my B. AB vector is acting vertical down direction. Okay. Then where is my BC vector? This is my BC vector. Right? Next one. CD vector is DC vector. Okay, my bad. DC vector. Not C to D. D to C. DC vector is upward direction. DC vector is upward direction. Now I will tell you this story. Look here. Look here. Now here we notice that these four vectors are arranged in a such a way their directions are flowing either clockwise or anti-clockwise. In this story, these four vectors are arranged in such a way the directions are flowing in the anti-clockwise direction. So therefore, initial point is here, final point is here, initial to final point straight line is the resultant vector. What will happen? What if one of the vectors arrow is in opposite direction? Now these two vectors are in the same direction, but when you consider BC vector, that is in this direction. Raise your hands in this story, sir. OD is result vector answer. So in case this vector's arrow is in this direction, how many we say? How many we say? Still, sir, resultant of these four vector same as OD answer. So no, since this one's arrow is opposite, therefore when you consider these four vectors, their directions are not flowing in one direction, either clockwise or anti-clockwise. See, these two are following kind of clockwise and suddenly it breaks, and this one is following kind of, sorry, my bad. These two are following kind of anti-clockwise direction and suddenly it breaks, and this one is following kind of clockwise direction. Again, this one is anti-clockwise. This one is going in a anti-clockwise manner. This one is kind of going in a clockwise manner. This one is again going in an anti-clockwise manner. So therefore, sir, these four vectors are not arranged in such a way to flow in one direction, sir. Therefore, if the arrow is this direction, resultant of these four vectors is not OD answer. Is not OD answer. Is not OD. It's not OD. So hands up now. Do you understand? Remember, if one of the arrows are opposite, if one of the arrows are opposite, remember you can't apply this polygon law. You can apply polygon law. Then you can't tell this is the resultant, right? The story you understand, right? You guys understand, right? Hands up, the people who came to my theory class from the beginning. The thing just that I explained right now. Hands up, understand, hands up. Genuinely? People who came to my theory classes from the beginning. Okay. Right? If you have a doubt, openly talk. If you have a doubt, openly talk. Now, simple story. Look here. Pythagoras, sorry, this triangle law. Triangle law, let's say you are 8 Newton is right side. You are 6 Newton is this direction. Can you consider, see, 8 Newton, 6 Newton. Can you consider this as the resultant? Can we consider this as a resultant? We can't. Why? When you are applying triangle law, first condition is after drawing first vector, you should start drawing the second vector. After you draw the first vector, from the point where you finish drawing the first vector, you should start drawing second vector. Right? And the most important thing is their arrows must flow in one direction. Their arrows must flow in one direction, either clockwise or anti-clockwise. Here, this one's arrow this direction. This one's arrow is this direction. Not creating a clockwise, anti-clockwise story. Right? I think you understand. If you have a doubt, ask. If you have a doubt, ask. I'll go back to the story again. Again, I'm going back to story. Right? If you don't have a doubt, small doubt, even the silly doubt, it's okay. Even your doubt is stupid doubt, also completely all right. I'm your teacher. You're asking doubt from me. I'm answering to you. Think the whole is class as an individual class, one-to-one session, because no one is nearby you. Maybe your mother or father, right? No, it's a one-to-one session. If you have a doubt, so I have a doubt. You can personally, you can put a message. I'm not telling this girl has asked a silly question like this. I'm not criticizing me. I don't not criticize also. So therefore, even the stupidest question that you have, openly share it. Openly share it. Why we should be afraid to ask questions? A to B, B to C, then DC vector is upward, then ED vector. Where is my ED vector? Here is ED vector is direction. ED vector. This is nice question. Look like confusing, look like complex, but not actually. ED vector is direction. And then what? EF vector. Where is my F? Here is my F. EF vector. EF vector is upwards. And then EF vector upwards. The next one is, the last one is FA vector right side. Now very clear, there are 6 vectors: AB, BC, DC, ED, EF, FA. Now we want to find the resultant. They are asking result on the 6 vectors. Now remember, some questions you can't, they don't give questions always to apply triangle law directly. They don't give always you to apply polygon law directly. Like this is a direct answer. Now they have given a diagram of 4 vectors. So they arranged according to polygon law. You just only want to see that. You just only want to feel that these 4 vectors are arranged such a way which describes in the polygon law. Are the initial to final resultant. All the times they don't give a vector diagram in that manner. Now this is somewhat complex. Now thinking, what can I do? So what can I do, sir? Sir, what can I do? What can I do? Sir, now I'm fully missed. I have no idea. I'm fully missed. I have no idea, sir. So what can I do? Sir, now, sir, now if I can't consider entire set of the vectors, sir, I break this vector system. There are 6 vectors. I break this vector system into 2. Likewise, I break into few sections and I try to find the resultants of those few sections. Sir, first of all, look here, sir. Shall we consider this ED vector and DC vector? Forget about remaining. Forget about this remaining entire story. I can't erase. If I erase it, I have to draw it again. Just imagine. Forget this entire EF, FA, AB, BC. When you only consider ED vector and DC vector, I draw it. Look here. Listen and learn. Don't keep any single doubt. All the doubts day by day getting together and it creates a very big confusion. Don't keep any single doubt. Openly talk and clarify it. Sir, this vector is, you are telling it is E. This vector is, you are telling it's ED vector. So this vector is DC vector. ED vector, DC vector. I'm going to ask you that. What is the resultant of ED and DC vectors? Just put some chat. Reply to the AS Academy. What should be the resultant of ED and DC vector? What should be the resultant of ED and DC vector? I know some responses. Now forget this entire diagram. Now only look at this diagram. Only look at this diagram. There are 2 vectors. There are 2 vectors. ED vector and DC vector. What should be the resultant of those 2 vectors? Put some replies. Put some replies. What is the resultant of ED and DC vector? Put some replies. Maybe right or wrong, doesn't matter. Doesn't matter. One is telling, sir, is it CE vector, sir? One student is telling, sir, is it CE vector? Another one is telling, it's EC vector, sir. So the resultant of ED vector and DC vector must be, sir, EC vector. One is telling like that. Other one is telling, sir, it's CE vector. Let's see others' comments. Sorry, EC. That's one also came to a point. It's EC. EC vector, sir. So it's easy. So it's EC vector. Anyone understand that? So according to the triangle law, sir, just start from one of the vectors. So shall we try to apply triangle law? So we'll try to apply triangle law. So I'm going to start drawing vectors from point T, sir. Then I'm drawing, first of all, I'm drawing EC vector, sorry, ED vector. I start from point T, I start drawing ED vector, sir. This is the point I finished drawing ED vector. From the point I finished drawing ED vector, sir, I'm going to start drawing my DC vector. I start drawing my DC vector also. I finished here. I started drawing here. I finished drawing at here, sir. So next story is look at the arrows, sir. ED vector's arrow and DC vector's arrow creates a same direction. Right? ED vector's arrow and DC vector's arrow, right, forms a smooth anti-clockwise direction. Right? Smoothly going. Arrows are going smoothly. Then, sir, according to the triangle law, sir, initial point is here, final point is here. Initial to final row straight line. Initial to final row straight line. Sir, This is going to be the resultant of these two vectors. So if I ask you, what is the resultant of ED vector and DC vector? If you add, look here, ED plus DC, resultant of ED and DC, if not addition of ED vector and DC vector, must be equal to what? So this is going to be equal to EC vector. Not difficult. Likewise, break. When you feel there's a very complex diagram, try to break into few categories. Then it's easy. Okay. Now, next tutorials I will tell you. I take time, it's okay. Next story. You know what does it mean by resultant of a vector? Resultant of, now there are vectors. What does it mean by resultant of a vector? We know. Now I am telling, you also agreed, sir, when you consider these two black color vectors, resultant of these two black color vector is this blue color vector. That means what? Rather than drawing these two vectors, to represent these two vectors, you can draw this single one. Agree? You guys agree? Rather than drawing these two vectors, to represent these two vectors, you can use the single one. Agree? So from this diagram itself, what I am doing, right? ED vector and DC vector I am removing. Careful listen. And removing the diagram. Instead of drawing ED and DC, I'm going to draw that vector. I'm going to draw that vector. Easy. See. Very beautiful. Physics really interesting. So EC vector. Yo, shit. EC vector. Hands up. How many of you understood why I removed these two black color vector and why I mark in the main diagram this blue color EC? Hands up. How many of you really understood why I have done that? If there are two twins, any one twin can replace another twin. Same, because they are same. Okay, that idea I don't explain why, no time. Okay, likewise, see, I am going to consider this story also. I am going to consider EF, FA, AB, BC. That story also I am going to take separately again. Now, for you to understand only I am doing these things, but upcoming days I am not. It's okay. Okay. EF, FA, AB, BC, BC. Look at carefully listen. Carefully listen. This is E. Time is finished almost. We start at 6:15. It's okay. A, B, C. But today you learn something. Likewise, every week we'll do. So now, if I look here, sir, look here, sir. How many vectors are there? Sir, there are EF one vector, FA second vector, AB is third vector, BC is fourth vector. So there are four vectors. So now, when there are four vectors, we can't think about triangle law, we can't think about parallelogram law. If there are four vectors, sir, we can think only the polygon law, sir. According to the polygon law, what it taught us, sir? Start from what are the vector? Start from the vector that you like. So I'm starting from EF vector. I started drawing EF vector from point E. Initial point is point E. I drew EF vector. For the point, I finished drawing EF vector. I am going to draw the next vector FD. But you told us the arrows must flow smoothly. The arrows must flow smoothly. EF to FA vector, arrows are flowing like this. Arrows are flowing like this. So then I finished drawing my second vector at point A. From the point where you finish drawing second vector, start drawing third vector AB. Arrows must flow smoothly. Arrows must flow smoothly. Right? Smoothly flowing arrows in same direction. Arrows are flowing smooth in same direction. I finished drawing my third vector at point B. Then you taught us, draw your fourth vector from point B. Arrows must flow, but you want to ensure arrows are flowing smoothly. Yeah, arrows are flowing smooth, you see. Arrows are flowing nicely, smooth arrows are flowing in these four. Finally, sir, I finished drawing my fourth vector at point C. Actually, I started drawing the vector at point T. I finished drawing the vector at point C. My question is, what is the resultant of these four vectors? Reply. What should be the resultant of these four vectors? Reply. What should be the resultant of these vectors? Reply. Now can na? No one explains like this level, huh? Reply everyone. What should be the resultant of these vectors? Everyone. Reply everyone. Reply. When you consider EF, FA, AB, BC vectors, what should be the resultant of these four vectors? Reply. EC. Again EC. One is telling FC. Always don't confuse starting point, final point. Your vector must be starting point, final point. Starting point, final point. Don't confuse that starting to final. Starting to final, don't confuse EC, 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 EC. Great. Everyone telling EC. Not AF. Think properly. Then initial point is E, final point is C. Therefore, the resultant of these four vector is it's easy. Question is also easy. Resultant of this four vector also easy. That means you can write down when you add EF vector, plus when you add FA vector plus when you add AB vector plus when you add BC vector, the addition of these four vectors. If not, we told the result of these four vectors is going to be equal to EF. Nice story. You are learning new stories. Sorry, EC, yeah. EC vector. So what can I do, sir? Then what can I do, sir? Rather than representing these four vectors, I can use the resultant of those four. Sir. Another EC vector. Right? Then you understand. Earlier there were 6 vectors. I realized those 6 vectors break into 2 vectors, EC vector. Still this question is not finished. We want to find the resultant. Right? There are 2 EC vectors right side. EC right side. Then we know the resultant going to be right side direction. So it's 2 EC, sir. 2 EC. Great question, right? Then time is 7:30 also. Time is 7:30. Hands up everything that we discussed so far. Crystal clear hands up. Hands up. So everything we discussed so far is crystal clear hands up. Crystal clear hands up. Hands up. Clear hands up. Clear. Right. See now, normally we do the class from 6 to 8. Last few weeks we didn't do, but upcoming days we are allocating this time for paper discussions also. In that case, we need time. Normally physics subjects. See now, theory wise finished, vectors finished, but still, even theory is finished, still we are learning stories. That's the nature of physics subject. Therefore, I want to do some additional lessons also. That means Friday, 6 to 8. Normally, I do the dude questions. Then in that case, normally 26 batch theory class is on Sunday, but I told them that I will start another theory class. I will put another theory class to finish the syllabus 6 months before for them. I'm planning to finish syllabus for 26 batch 6 months before. That's the plan. Then 2 theory days, pass the discussion 1 day, and we are writing papers now here after every week for 26 batch. Every week we are writing a paper. Every week that's a paper. Every week it will be marked. For your batch also, that's going to happen very soon. Then definitely we need more time if you want to learn physics properly. And then we have done around 12. We have done around 10 questions something. Don't worry. Likewise, next week also we can do. Next week we'll do exactly. We'll take a. Next week Friday. Next week I think there's a poll day. I don't know next week or not. Not next week. 8th one is poll. Next week 1st. August 1st is next week. First 8. Anyhow, I normally do many sessions, right? Without clashing you people's classes also. Let's talk this. Let's talk this and let's sort out this. Now from this exposure, try to do the pending questions. Try. Now you might have tried the questions, then you could not get the idea. These questions you have no idea. But now you have the idea. Based on this idea, try to do the questions. Again, sometimes you can't do the question. Again, I am explaining. But what is important is after completing every session, it doesn't matter you got 9 ASO, you got 9 WSO, it doesn't matter. After every class finishes, just you go and just drink some water, eat something, and come and again sit in the chair. And what you do, redo these questions once again. That is mandatory. That is mandatory. Once again, redo it by yourself on. And okay, just raise your hands. Today we didn't do anything big. Raise your hand. Session is very effective answer. We had on around 1 hour time period only. We had on only 1 hour time period. Session is very effective answer. It's effective. It's effective. It's effective. Even you say not effective, I know it's effective. Okay, I know it's effective, right? Okay, then you just do your other subject works and study well. I have another class for 26 batch, 25 batch paper discussion from 7:30 to midnight, 12:30 maybe. Okay, at what time? I don't know at what time it finishes. 50 MCQs want to discuss. Not like this. It's a big MCQs. Just go and search in my YouTube. Refer that Monday, there's a video, Fluid Dynamics live classes. And you see some drive dragons. Okay. Okay, take your break. No. Then, okay, finished. Not break, finished, huh? And see you, bye.